In this video, I'll show you how to use the sine law to solve a triangle. The sine law relates the sides and the angles in any oblique triangle. An oblique triangle is a non-right triangle. So if you ever run into a situation where you need to find the side lengths or the angles of a triangle that is not a right triangle, such as one that is acute or obtuse as shown here, you would use the sine law, which is stated right here. Let's jump into an example to see how we can use the sine law. The question reads, what is the length of side D in triangle DEF? Now it's important to note that you use the sine law as opposed to the cosine law, which will be discussed in another video, when you have the following configurations: angle, angle, side, side, angle, side, angle. And it helps to memorize these. So let's make sure whenever we answer a question, we write down the following patterns: AAS, ASA, and SSA. And these patterns are different if, say, you are given a triangle where you have to use cosine law and you have to distinguish between the two. Let's find out if this is a candidate for the sine law. What we have is we have a side, an angle, and another angle. Side, angle, angle. Does this work? It does. So we know that this triangle is a candidate for the sine law. So let's figure out side D. Now, what we have, you have to scan the triangle to see if there are any completed side lengths to angle. And what I mean by that is notice that this side length right here, which is 38 centimeters, has a completed opposite angle. Now, since this remains true, we can use the sine law. Now, what I'm going to do is I'm going to write down the sine law. Sine A over little a, and sine B over little b, and sine C over little c. Now, what I like to tell my students is that if your triangle is not in the A, B, and C configuration, feel free to make it into the A, B, C configuration. So if that helps you, then do it, and I will for the sake of this demonstration. So D will become A, E will become B, and F will become C. So what we have is we have a completed B, and I'll write that in. We have sine angle 95, and we have a side length of 38 that corresponds to it. And also, we need to find A, but we have the angle for A, so that's great. And so we have sine 40. Now, if you do change it to A, B, and C, make sure you change it back once you finally find the variable that you were looking for. And increase the space here. And we're looking for A. Now, to find your missing variable, you have to cross multiply. And for some cases, it's easy, and for some, it's not. So I'll show you how to do it stepwise. The first thing you'll do is you'll start at the bottom left corner. In our case, it's an A. You're going to multiply your A by this number. Sine 95 times A. And this little dot represents multiply. And here we have 38 times sine 40. And many students, what they will do is they will evaluate this side and come up with a number, a decimal number, and they'll evaluate this side and come up with a decimal number and write it down. And then in the end, they get a number that is a little bit off from what the teacher is expecting. So to prevent that from ever happening, since we are isolating for A, we can divide both sides right now by sine 95, and we don't have to evaluate sine 95. We don't have to plug it into our calculator just yet. And we divide both sides by that. And then on your calculator, if you are a little tech savvy, you can put this all in one step, and that's recommended. So what we have is 38, I'm going to evaluate the top part, times sine 40 divided by sine 95. Oh, that's a mistake. So I'm just going to go back to what I had originally. That divided by sine 95 is equal to 24.5 as a side length in centimeters. Now, since they wanted us to find what side D was, we're going to assume that A is equal to 24.5, which is equal to D. Now we're going to move on to another example, just so that we are perfectly clear with the sine law. And in this example, they are asking us to calculate the measure of angle Z. So this time they want us to find an angle Z, and they want us to determine the unknown side lengths of X and Y. So there's a little bit more to do here. And the first thing that I'll do is write down the patterns. AAS, ASA, and the last one was side angle. So let's see if this triangle fits this criteria. We have angle, side angle. Ah, there we go. So yes, we can use the sine law. Now we're going to start off by finding angle Z. And angle Z is very easy to find because we know that a triangle sums up to 180 degrees. And we have two of the three angles. So we can subtract 180 from 83 from 35. And we get angle Z is equal to 180 minus 83 minus 35 is equal to 62. Excellent. So I'm just going to fill this in, 62 degrees. The next thing that we need to do is find out Y and X. And let's start with finding out Y. So in this case, we have a completed side length to angle. And once again, I'm going to use A, B, and C. A, B, and C. And we have sine 62, which we just found, over 2 feet and 2 inches. Now, 2 feet and 2 inches, you will need to convert that into strictly feet or strictly inches. And for every 1 foot, you have 12 inches. So in this case, we have 2 feet, which is 24, 2 times 12, plus 2 is equal to 26 inches. So make sure you do that. Make sure you convert this into 26 inches. And now we can go ahead and find out what Y is equal to. So 35 is the corresponding angle to side length Y. To solve for Y, we will cross multiply like we did in the previous example. And we're just going to keep this open. We're going to have 26 times 35 divided by sine 62. 26 times sine 35 divided by sine 62. And we end up with 16.89 of a side length that represents side Y. We'll also do the same for X, and we will use the exact same ratio, completed ratio that we had above, but instead of sine 35, we're going to use sine 83. So let's do that. Sine 62 over 26 is equal to sine 83 over X. Now, in case you were confused with the previous calculation, I'm going to show you this one more clearly. You multiply across and also across this way. 26 times sine 83 is equal to sine 62 times X. To find out what X is, you divide both sides by sine 62. And we end up with 26 sine 83 over sine 62 is equal to, we're going to use our calculator, 26 times sine 83 divided by sine 62 gives us an answer of 29.22. Therefore, length x is 29.22 inches, and side length y is 16.89 inches. And it appears that it is to scale. So there you have it. That is how to solve oblique triangles, non-right triangles, using the sine law.